Hi everyone. Saya ingin mengambil kesempatan untuk mengucapkan ribuan terima kasih kepada PBD Sibu iaitu Pejabat Pendidikan Daerah Sibu kerana telah merancang dan melaksanakan program iaitu Towards Excellence in SPM. Apakah matlamat program ini? Matlamat program ini supaya pelajar mendapat input pembelajaran berfokus secara alam maya dan dilaksanakan secara friendly learning environment. Dan objektif program ini, kami berharap di akhir program ini, pelajar dapat memperolehi dan mengaplikasikan pengetahuan dan teknik baru dalam mengekal dan meningkatkan kecemerlangan akademik. Pelajar juga dapat meningkatkan pencapaian akademik sehingga ke akhir program ini. So, first of all, I would like to introduce myself. My name is Mr. Chai Tekyong, who teach at SMK Rosalie Dobi, and my partner is Madam Wompohi, who teach at SMK Kampong Nangka. So both of us are given a task to do the PowerPoint of this presentation and the video of this presentation on the very important topic. There's two topic here, a very important two topic here, which is rate of reaction and thermochemistry. So in this rate of reaction chapter, which is at Form 4, there's a 4 factor that affecting rate of reaction, which is size of reactant, second, temperature, third, concentration, and the fourth is catalyst. All right, so let's go now. We come to a question which I will try and help the student to guide you to obtain the answer and how to write the correct answer. Okay, so let's read the question 1. 2 sets of experiments are carried out to investigate one of the factors that affects the rate of reaction between 100 centimeter cube nitric acid of 0.5 mole decimeter cube and 2 grams of zinc. So you must know that there's a 2 reactant here, which is nitric acid and the zinc. Okay, so you also must know the factor here may affect maybe the concentration here and also the size. Okay, size. Okay, so let's see the diagram here. Okay, diagram below shows the curve of the graph of volume of gas against time obtained from the 2 sets of experiment, set 1 and set 2. So this diagram, we can see that the curve of the set 1 is steeper than the set 2. So what does it mean? So of course, when the curve of the set 1 is steeper, meaning that the set 1 has a higher rate of reaction than set 2. Right. So the first question is state the meaning of rate of reaction. How am I going to guide you to write the correct answer for this definition? So this definition, so you can refresh back. What does mean the rate actually? Okay, so we can refresh back. Actually, the rate is like how fast or how quickly the reactant is converted into the product per unit of time, over the time taken or per unit time. Because when you come to the rate, you need to compare per unit time for the fair comparison. Am I right? So how are we going to measure the rate? Of course, we can see or we can measure the quantity of the reactant used up over the time taken. Or You also can measure the quantity of the product formed over the time taken. So when you're going to write the meaning of rate of reaction, of course, you cannot write in the formula like this. This formula, for sure, you cannot write because this formula is in the form of mathematics is for the calculation. But the meaning here, you are not allowed to write in formula. So how are we going to write in the sentence? So the first word is the change. So remember that the first word is very important, is the change here. Okay, so change in what? So change in the quantity. So this quantity can be referred with the mass of the reactant or the volume of the product. So you can just write in the quantity in the general form, quantity of a reactant or product per unit time. So per unit time is mandatory, which is compulsory, must write in, okay? Because rate is must refer and relate to the time taken for the quantity of the reactant used up or for the quantity of the product formed. All right. So hope that student can get it how to write the correct definition of rate of reaction, which is the change in the quantity of a reactant or product per unit time. So the second question is, state one observable change in this experiment that can be used to determine the rate of reaction. So how I'm going to guide you. So let's see this diagram, which I have put here. So when you see this diagram, which one you're able to measure, which one you're able to observe. Of course, one is the product here, which is hydrogen gas, which you can measure what? Which you can observe what? You can measure or observe the change in the volume of gas. Am I correct? So what is the change of the volume of gas? You can see the increase in the volume of gas. Or you also can see the measurable of the zinc here, the reactant here. What we can measure, what we can observe here is the mass of zinc. So what we can see here, you will can see the decrease in the mass of zinc when the zinc used up. Am I right? So the answer will be, what is observable change? The change is increase in volume of gas. So this volume of gas is the measurable and the observable that we can see. Or you also can say decrease in the mass of zinc. So mass of zinc is the measurable and the observable change that we can use to determine the rate of reaction. All right, then we go to the next slide. Okay, now this question C is about kebab, hot question. Why I say this is hot question? Because it use daily life situation. Any things that question, the stimulus of the question that use a daily life situation, like when you learn the rate of reaction, you apply your daily life situation. So this is a kebab, or we call hot question. So the hot question is, in which situation will the meat cook faster? Explain. So the marks allocated here is 3 marks. So how you're going to answer it in which situation? I think all the students here able to answer in which situation will the meat cook faster. Of course, is situation A. Why? Because it cut into smaller slices. Am I right? So the answer sure is situation A. But still not yet. All right. The questions they ask you to explain. So another 2 marks, you must able to explain why you choose situation A. Why? So because the satay here has a bigger total surface area exposed to heat. So I remind the student here, don't just write bigger surface area without the word of total here. The total here is very important here, because if you just write surface area, maybe you just refer the surface area at the top one, or just surface area at the bottom one, or left side or the right side. So you must refer to all the surface area. So the word of the total you have to put in. Okay. So when you cut into smaller slice, I think you all know that satay will has the bigger total surface area exposed to heat. Am I right? So are you able to think the last point, which is will contribute the third mark from here? So how I'm going to guide for you, so you can think of when you cut into smaller slice, then it has a bigger total surface area. So which one will absorb more heat energy? Because when 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 they absorb the more heat energy, for sure the rate of the cooking will be higher, right? So of course satay here will absorb more heat energy. So the answer is, when satay has a bigger total surface area, so it will be more heat energy is absorbed. So the satay will cook faster in the situation A. Okay, so it's simple, right? I think you all can do it. Yeah, I'm so excited now. All right, so we come to question 2 here. All right, table below shows the information for 2 sets of experiment to investigate one factor affecting the rate of reaction between zinc and sulfuric acid. Oh, so here is investigate the one factor. So what we can see here, do you see in the set 2 here, there is a catalyst, okay? Okay, so based on the table, what is the meaning of catalyst here? All right, a chemical, the first word is a chemical, or you can simple, if you want to put a substance, also can, but I prefer appropriate word that is called a chemical or chemical substance, is able to change the rate of reaction. Maybe a student will write a chemical that is able to increase the rate of reaction. That's it correct? Yeah, it is correct as well. Why? Because based on the table, the catalyst X just now really can increase that rate of reaction between the zinc and the acid. Right? State the name of the catalyst as used in set 2. So the students are able to name the catalyst as. Remember, student, remember that catalyst is specific in its action. What does it mean, specific in its action? It can only catalyze a particular reaction, meaning that you can also simply just use any catalyst that you know. Okay, for example, what are the catalysts that used for the reaction between zinc and acid? For sure is the CuSO4 solution. But the keyword, the name, the keyword, the question asking you to name it. So when you want to name it, you have to write the name is copper to sulfate. Don't just write CuSO4. If you write formula, I'm sorry, you won't get the mark. Okay? Okay, so please read the question carefully and answer carefully as well. All right, so now we come to a very simple calculation. So calculate the average rate of reaction in set 1. Okay, so how are you going to calculate average rate of reaction in set 1? Of course, just now what we have learned in the definition of rate of reaction is the change in the quantity. For here is the quantity of the product. So quantity of the product here, you look at the volume of gas, which is 30 centimeter cube that collected over over what is the time taken here is 2 minutes here. So you just simply make a calculation is 30 centimeter cube over 2 minutes. So you can get the answer is 15 centimeter cube per minute. So bear in mind, student, when it comes to the final answer, you must put correct unit. Okay? Always remember, final answer must with the correct unit. Okay, step 2 here is the same thing. When with the catalyst X, the volume is 50 centimeter cube that is being collected from over the 2 minutes. So you can get 25 centimeter cube per minute. So what we can see here, the average rate of reaction in set 2 sure is higher than the set 1 because of the presence of catalyst. Okay, compare. So I think you all able to compare the rate of reaction because set 2 has catalyst. So the function of the catalyst here is increases the rate of reaction. So you write the rate of reaction of set 2 is higher than set 1. Remember, student, please don't write set the rate of reaction of set 2 is faster. Don't. Okay? Faster cannot use if you are use the word of rate here. So because rate here is about like a value. When come it's like a value like change in the quantity of the product from here over the time taken. So you need to use the word of higher, like which value of the rate here is higher. So don't use faster. So if you use faster, I'm sorry, you will get wrong. Okay? No mark will be awarded for you. So remember that. Don't use the wrong term, which is faster for the rate of reaction. So are you able to explain your answer in C2 based on collision theory? Okay, so how I'm going to guide you here for these 3 marks. Okay, so if you look at this energy profile diagram here, okay, the blue line here, okay, I can see the blue curve is the activation energy without catalyst. So the blue line here meaning that the activation energy that without catalyst is higher, which is here, the blue line, okay, here, are you able to see that? So this is the activation energy that without catalyst, which is higher one. But how about when you add the catalyst? When you add the catalyst will provide an alternative path, okay, an alternative path with a lower activation energy. Am I right? So you look at the blue line here. When you add a catalyst, it provides another alternative route. Okay, so meaning here, so this is the activation energy that with catalyst, which is lower than the activation energy without catalyst. So this is you need to write in your first point. Catalyst provides an alternative path with a lower activation energy. So when you come to a lower activation energy, what is the benefit? So we come to this analogy here. Okay, so you look at the mountain here. So that you see the diagram, okay, the mountain that they show here. So we can see there's a 5 stones that are roaring up. Okay, go to the top mountain, but I think it takes a very longer time to roaring up to the very top mountain as because activation energy is higher and maybe a few stones that able to roar up. But what is the effect of catalyst when you add in? It means that the 5 stone can roll to the another root. Yeah, you go to the another root which the old stones can able to achieve the lower activation energy with a shorter time. All right. So you can write is more how you're going to write when you come to the chemical reactions, which is more colliding particles. More colliding particles can achieve a lower activation energy. All right, simple, right? So then when you have a result, of course, you can write the last point is the frequency, or you also can write the rate of effective collision. So when you have a result, of course, you have to mention this effective collision and write frequency because you need to compare per unit second here. So the frequency of effective collision between zinc atoms and hydrogen ion increases. Remember, class, remember, student, the name of the particles that involve in the collision you need to write. Okay, just now the question is about the zinc and the acid. So what are the name of the particles that involve in the collision is zinc atoms and hydrogen ion. We remember you have to use particle. So the particle from the acid, of course, is hydrogen ion. Okay, the hydrogen ion is the main particles that involve in the collision that produce the result. All right. Okay. So I hope that you're able to get it. So there is a tips here. Okay, to guide the student to write the collision theory. As collision theory is very popular, are frequently asked in the SPM. For example, like when you want to write explanation based on the collision theory, so you must know what are the factors that involve. Is it size of reactant? If size of reactant, then you write smaller size. That that give the higher rate of reaction. Is it concentration of acid? If factor is a concentration of acid, then you have to write higher concentration of acid that gives the higher rate of reaction. Also, is it temperature that involved? If temperature that involved, you have to write higher temperature that produce the higher rate of reaction. So what is the effect here? The main function here. So if smaller size, if smaller size, so the main function here, of course, will have the bigger total surface area. All right. Or if higher concentration here, of course, the higher number of hydrogen ion per unit volume. Yeah, okay. So this is the function, the main function of the main effect here. What happened to the, if you have a higher temperature here, so if you have a higher temperature here, of course you have the higher kinetic energy. Yeah, kinetic energy here. So you also have to compare the frequency of collision between the name of the particles that involve the collision to produce a result. And the last one, don't forget to compare the frequency of the effective collision. All right. So how about the strong, if the question are given a strong monoprotic acid and a strong diprotic acid. So the rest is the same, but please take note that you need to state the type of the basicity of the acid, which like if given is hydrochloric acid, you have to say hydrochloric acid is a strong monoprotic. If sulfuric acid is given, so you have to say, wow, sulfuric acid is a strong diprotic acid. Okay, so please take a note. You need to state a type of basicity of the acid, then compare the concentration of hydrogen ion, which is concentration of hydrogen ion produced by the sulfuric acid is double than that of hydrochloric acid. All right. So this is the tips that in the table form that can guide you to get the full mark in collision theory. All right. So let's train ourselves to do this about collision theory. So table below shows the information for 3 set of experiment to investigate the factor. So you need to see what are the factors that involved here that are affecting the rate of reaction between the calcium carbonate and the hydrochloric acid. Okay. So based on the information in table above, compare the rate of reaction between the set 1 and set 2. So we look at the set 1 and set 2 here. So what are the factors that involve here? So I got you. Let us highlight the word of powder here. So meaning that it refers to the size of reactant. So the powder here means it has a smaller size here. All right. So of course, compare the rate of reaction first. You write the rate of reaction in experiment set 1 is higher. Why? State the factor. What are the factors? Yeah, I know. I think the student know, right? The size of calcium carbonate in set 1 is smaller. Yeah. Okay, remember, write calcium carbonate. Don't just write reactant, size of reactant, because you have 2 reactants here, calcium carbonate and the hydrochloric acid. So which reactant you are referred to, please specify it. So you need to write the size of calcium carbonate in set 1 is smaller. And how about the main function just now? Do you still remember the tips of the table that I showed you just now? So the main function, the effect is the total surface area. Remember, the word of the total is a mass, TSA, the total surface area of calcium carbonate powder exposed to collision is bigger. Yeah. Then what happened to the frequency of collision? The frequency of collision between the name of the particles that involved here is hydrogen ion, which is from the acid, and calcium carbonate in set 1 is higher than set 2. So remember, student, from the particles that involve from the calcium carbonate powder here is CaCO3. Don't write carbonate ion. The correct concept here is calcium carbonate is insoluble in water. So calcium carbonate, when it is insoluble in water, so hydrogen ion will only collide with the calcium carbonate here, which haven't dissociated. Okay? Yeah, because it is in solid form, it does not dissolve in the water, so don't dissociate it into a carbonate ion. So you just write CaCO3 is enough to collide with the hydrogen ion to give the result. So the last one, okay, remember the frequency of effective collision in set 1 is higher than set 2. All right. Okay, so I think you're able to get it right, this collision theory. So why not we practice again, as more practice make it perfect. Am I right? So we continue again with the set 1 and set 3. So what is the factor involved here? So what we highlight and circle here, we can see that the hydrochloric acid here, the concentration of the acid given here is different. So compare the rate of reaction first. Of course, for sure, the set 3 now, the rate of reaction in experiment set 3 now is higher than the set 1. Why? Because the concentration of hydrochloric acid, or you also can write hydrogen ion in set 3 is higher. All right. So do you still remember what is the main function of the effect from the higher concentration? It gives higher number of hydrogen per unit volume. So remember, hydrogen ion, the particles that the main role, the main particles, the take part in the collision here is hydrogen ion. So you have to write the number of hydrogen ion, and remember per unit volume is a must have to given because you are referred to the concentration. So concentration is referred to the number of the number of the solute or the number of particles that dissolve in 1 dn cube of water. So you have to write per unit volume for the fair comparison that dissolve in 1 dn cube. So you have to write per unit volume. Okay. All right, then come to the next one, which is the frequency of collision between hydrogen ion and calcium carbonate in set 3 is higher than set 1. Yes, so just now I do already explain to you. So the specific name of the particles that involve is hydrogen ion and calcium carbonate. So the last one, you still remember, student? What is the last one that produced the result? Which produced the result? Of course, the set 1 produced the result faster, right? No, set 1, sorry. It's the set 3 produced faster, right? So you have to write the frequency of effective collision in set 3 is higher than set 1. All right? Okay, sure. No problem. All right, we continue. How about more practice really make it perfect? How about this question right now? Chemical equation below shows the reaction between hydrogen gas and chlorine gas to produce hydrogen chloride gas. So set 1 and set 2 in diagram shows the rate of reaction of formation of hydrogen chloride gas at different temperature. So we can see that there's an unknown temperature given here, which is X and Y. Okay, so which one has a higher temperature? Okay, let's see. If the two sets of S reaction occurs at temperature of 30 degrees Celsius and 40 degrees Celsius, determine the temperature of X and Y, X in set 1 and Y in set 2. Oh, how you gonna to analyze based on this diagram? Of course, we look at the product. So this is your product. Am I right? Okay. So this is your product. One black and one white, meaning that this is referred to the hydrogen chloride molecule, which you already produced the product. But I can see here in the 22nd, another one reactant still not converted into the product. But when you compare to here, all the product already converted into all the reactants already converted into the product in 20 seconds. So I think you know which one is higher rate, right? Of course, the set 2 will be the higher rate. If the set 2 is higher rate, so what is X and Y? Of course, Y degrees Celsius will be the higher temperature. So how are you going to write? X is 30 degrees Celsius. Y will be 40 degrees Celsius. Okay? I hope that I can help you, students. With reference to collision theory, explain why there's a difference in the rate of formation of hydrogen chloride gas in set 1 and set 2. Oh, what's the difference? You tell me which one rate of formation of hydrogen chloride gas is higher. Of course, it's set 2, right? Yeah, the rate of formation of hydrogen chloride gas in set 2 is higher. Why? Please take the factor. You still remember the factor here? 40 degrees Celsius, what does it mean? It means higher temperature. Yes, the temperature in set 2 is higher, while in set 1 is lower. Then the main function is the kinetic energy of particles in set 2 is higher than set 1. Yeah, okay. So when you come to temperature, you have to relate to the kinetic. It means that it moves faster at a very high speed. Okay. What's the next point? Just now we already more practice make it perfect. So you need to mention about the frequency of collision between what? So what is the particles that involved here is the hydrogen molecules and chlorine molecules. So bear in mind, here must be between the name of the particles. So when it comes to particles, you need to mention the word of molecules. If you not mention about the word of molecules, I'm very sorry, you won't get a mark. Okay, so be careful. All right. So the last one, when you produce the result, okay, so the frequency of effective collision in set 2 is higher than set 1. Okay. All right. Then we continue again. All right. Oh, sketch now. Sketch the graph. Question 5. Sketch the graph of volume of gas against time for set 1, set 2, set 3 on the same axis. Are you able to draw a sketch of graph? Please look at the table carefully. You have 3 different time taken here, which the shortest here is 30. When it comes to the shortest here, means this has a higher rate of reaction, right? So followed by 55, followed by 90. Okay? Yeah, all right. Okay, so must remember, so time taken to collect 40 centimeter cube of gas. Okay, please remember there's a 30, 55, and 90. So meaning that you need to plot around like this. Okay, I sketch initially first. Okay, to show you like we have a time, like we have a 30 here, we have a 55 here, okay, we have a 90 here, and we have a 40 here. Like this, the volume against time. So then how you gonna to draw? Okay, so make sure you put like a dotted line. Make sure you only reach 40 here. So I think you know the highest rate is set 1, right? Because it gives a shortest time. Yeah, all right. How do you know? You look at the factor here. The powder, smaller size. Okay. So the set 3, I use granule. Even though the set 1 and set 2, I use smaller size, but you can look at the concentration here, which is set 1 is the higher. So you will get the highest rate among the 3 experiments here. So when it comes to highest rate, you can just like this. Okay. Oh, okay. Okay, why not I show you the correct answer here, which is like this. So remember, okay, what you should do, you must have the what you call the title of your assets. Okay, so your title of your assets must write volume of gas, must follow by the unit against the time, must follow by the unit. Okay, so this is a must have volume of gas against time with the unit. So you must remember to plot. There's a time taken here is 30, 55, 90, and the volume is 40. So what I show you just now, when you know the set 1 is the highest rate, so you draw the curve of the set 1, just draw the curve and stop at the 40. So don't draw a constant line like this. Sorry. Constant line like this. Don't draw a constant line. Okay? No, this is wrong. Because 40 centimeter cube is not the maximum volume for all these experiments. Okay? It just fixes the volume. It fixes the volume of 40 centimeter cube. Then it measures the time taken to collect the fixed volume of gas. This is another way to measure, to compare the rate of reaction as well. Okay? So this is the correct curve of the graph of the 3 experiments, which is set 1, followed by the Sec2, and followed by the Sec3, which the Sec3 has the lowest rate of reaction. Okay, thank you. Okay, now we come to the next chapter. Okay, so I done already with the rate of reaction for the Form 4 chapter. So I hope you all can more understand about the rate of reaction and more understand the technique of answering the question, especially when it comes to the collision theory. So I hope students are able to understand more on this Form 4 chapter, which is rate of reaction. So now there's another topic here is very popular in the Form 5 question, which is called thermochemistry. Okay, so we will learn is what is the difference between exothermic and endothermic reaction here. And there's a 4 heat of reaction we'll learn, which is heat of precipitation, heat of displacement, heat of neutralization, and last one is a heat of combustion. Okay, now we look at the question 1. Diagram below shows the energy level diagram for 2 different chemical reactions using hydrochloric acid. So when we look at this diagram for the between the reaction 1 and reaction 2, there is one is an exo, one is an endo. Am I right? So okay, I think you are able to identify which is an exothermic and which one is an endothermic. Huh? Okay, so based on the diagram, suggest L and N and determine the sign of delta H for both reactions. Compare and deduce the information that can be obtained from the energy level diagram for reaction 1 and 2. So first, the question task is suggest L first. Are you able to suggest L? What is L? Of course, you're able right. If you look at here, you are produced, one is salt and water. I think you know this reaction is called neutralization reaction between between acid and alkali. Are you able to name the alkali that used to form the salt, which is sodium chloride? I think you're able to name it, right? So it is sodium hydroxide. Yeah, correct. All right. So how about the delta H? The question asks you to determine the sign. Is it positive or is it negative? If you're able to identify that this energy level diagram is exothermic, so the sign for this delta H here, of course, for sure is negative. Yeah, so the negative sign here is referred to the exothermic. Okay. How about reaction 2? So you know that reaction 2 is endothermic, right? So what is M? So when student write here, or when see there's a salt here formed, carbon dioxide gas, and water. So the student must able to identify the M should be a carbonate. Carbonate that react with the acid will produce the salt, carbon dioxide, water. But unfortunately that a lot of students will mention is sodium carbonate. So unfortunately, the sodium carbonate is wrong because sodium carbonate that you use here will give an exothermic reaction, will not give endothermic. So what are the carbonate that can give endothermic reaction that produce the sodium chloride, which is sodium hydrogen carbonate. Okay. So please remember there's one carbonate then can produce an endothermic reaction, which is called sodium hydrogen carbonate when react with the acid it will produce salt, carbon dioxide, and water. Or the other name that we also can call sodium bicarbonate. So if you notice, this is an endothermic. So why the sign here? The sign here is called positive, which is referred to endothermic. All right. So how are we going to compare the difference between this exothermic and this endothermic? Are you able to give the difference? So the first difference you can tell me based on the delta H sign that you give just now. So you tell me what is the type of reaction? Is it exothermic or is it endothermic? Then after that, from the energy level diagram, you look at the total energy content of the reactant and products. What's the difference in the total energy content in the reactants and products? And how about energy change during bond breaking and bond formation? Yeah, so you can build in the table form, okay, to show the difference between these two reactions. So this is the answer. So first, what is the type of reaction? So reaction 1 is exothermic. Or you also can say the reaction that release heat energy to the surrounding. Or reaction 2 is called endothermic, which you can say that reaction absorb heat from the surrounding. All right. So the second difference is the difference in the total energy content of the reactants and the product. So if exothermic, you have to write the total energy content of reactants is higher than product. So when it comes to reaction 2, it will be the vice versa, that you should write total energy content of reactant is lower than the product. So how about during the bond breaking and bond formation? So if reaction 1, which is exothermic, is about release heat, so meaning that the total heat energy that release during the bond formation must be greater, right? So you can say heat energy absorbed during the bond breaking is lower, should be lower, right? Than the heat energy release. So mean that the heat energy released during the bond formation will be greater. All right. So when it comes to reaction 2, will be the vice versa, which reaction 2 is the absorbed heat energy. So heat energy absorbed during bond breaking is higher than heat energy released during bond formation. Okay, I hope that I can help you able to differentiate exothermic and also endothermic reaction. Okay, now we come to question 2. Diagram below shows the energy level for the reaction between silver nitrate and sodium chloride. Write two statements that be concluded from the diagram. So just now we also give a difference between the based on the energy level diagram that given just now. We also give a different, okay, to give a different from the two energy level diagram, right? So here, what the two statements that can be concluded? Yeah, you look at the sign of the delta H again. Yeah, what the sign here, what I can see here is a negative. So what are the statements that you can write? First is the reaction is exothermic. Or you can say the reaction is released heat energy to the surrounding. Okay, what else that can be concluded from the energy level diagram? Here you see there's a negative 65.5 kJ per mole. So this value is referred to the heat of precipitation because this reaction is referred to the precipitation reaction which form silver chloride salt, which is insoluble salt. So there's a one statement that you can be conclude is heat of precipitation is negative 65.5 kJ per mole. And or only two statements, but if you want to write there's another answer that we can accept is the difference of the total energy content of the reactant and the product. So if you look at the level here, the total energy content of the reactants, which is Ag9, silver nitrate, and sodium chloride, is higher than the total energy content of the silver chloride and sodium nitrate. Simple, right? I think you're able to do it. Okay, so just write two statements that can be concluded from the diagram. Okay, question B. If the sodium chloride solution is replaced with potassium chloride solution of the same concentration, predict the heat of precipitation for the reaction. Give one reason for your answer. Okay, so this question is mentioned that if the reactant sodium chloride is replaced with the potassium chloride, does it will affect the heat of precipitation? So remember, student, what does it mean? Ionic equation that involved in this reaction, meaning that the reaction only involves silver ion from the silver nitrate solution and chloride ion from the sodium chloride solution. Even though you change to the potassium chloride solution, the reaction still involves chloride ion only. So it will not affect the heat of precipitation because you still produce the same precipitate. Yeah. So your answer is still the same, or you just write the heat of precipitation is still negative 65.5 kJ per mole. And what's the reason? Of course, sodium and potassium ions are not involved in the precipitation. Or in another way around, you can write sodium and potassium ions are spectator ions. So it will not affect because it's spectator ion. Okay. Or we also can accept like the reaction only involve silver ion and chloride ion. Okay. All right, we come to the question 3 here. Diagram below shows the results of 3 different experiments for the reaction between copper 2 sulfate solution when reacted with excess zinc in experiment 1, 2, and with excess silver in experiment 3. Okay. Okay, this is the 3 experiment. Okay. So let's see the question. Okay. By comparing experiment 1 and 2, predict the value of T1. So where's the T1? You look at the diagram, or you need to predict the highest temperature here. All right. How I will guide you to get the answer. So we look at the stimulus from the experiment 1 first. Okay, so you look at the concentration. Why you look at the concentration? Because the concentration will affect the change in temperature. Okay, I repeat that. Concentration of the solution will affect the change in temperature. So if experiment set 1 is used 0.2 mole per decimeter cube, so the reaction cost increased by 5 degrees Celsius. So initial temperature is 28. So increased by 5 degrees Celsius, you will get the highest is 33 degrees Celsius. So when you repeat with the experiment 2, we can see that the concentration of the copper 2 sulfate solution here is double, 0.4. So when it's double, what will happen to the change in temperature? It will also double it from the 5 degrees Celsius times 2. So when from 5 degrees Celsius times 2, you will get 10 degrees Celsius. So when you get 10 degrees Celsius, so 28, 8, 10, okay, plus 10, you get the highest temperature will be 38 degrees Celsius. So the answer for the T1 is 38 degrees Celsius. This is the way how you predict the value and analyze from the diagram. Okay? Oh, not yet. The question asks you to explain. Are you able to explain why 38? Why the change in the temperature is double? Because the concentration of copper to sulfate solution is double. Or you also can say higher. All right. So when concentration of copper to sulfate solution is higher, so it will cause the number of mole of the copper to sulfate solution used is double, or meaning that the number of mole of copper that is displaced also will be double as well. Okay, so this cause the temperature change is double. Okay, I hope that I can help you. All right, how about experiment 1 and 3? What's the difference here? So when it comes to experiment 3 here, meaning that it use excess silver, no more is zinc. So you have to remember, can silver react with the copper to sulfate solution? No, silver not able to react with the copper to sulfate solution. Why? Because silver is less electropositive than copper. So if there is no reaction in this experiment set 3, what will happen to the change in temperature? So no change. So highest temperature still 28 degrees Celsius because no heat is released. So there will be a no increase of the temperature here. So are you able to explain another 2 points here? So you have to tell me why you use silver. There's no reaction because silver is less electropositive than copper. So when silver is less electropositive than copper, is there any reaction? Reaction does not occur. Or silver cannot displace copper from its salt solution, or there is no heat released. That's why you don't get increase in temperature. So what is your predict for T2? For sure, still 28 degrees Celsius. All right. Okay. So now we excited to go to the next question. Excited, right? So let's go to the next question. Oh, here is another one K-BAT question here. Why K-BAT? Because it is a daily life situation when we learn about exothermy, how you're going to apply in the daily life situation. So we see this diagram shows how stock solution, okay? Stock solution means it's a higher concentration one of sodium hydroxide is prepared by a lab assistant. So explain why the lab assistant use. See that the beaker, okay, they are put the beaker into another beaker here with ice, okay, use ice to add her preparation of sodium hydroxide solution. And there's a calculation here when 1 mole of sodium hydroxide is dissolved in water, it produces 44.5 kilojoule of heat. Calculate the temperature change if 0.5 mole of solid sodium hydroxide is dissolved in 800 centimeter cube distilled water. So first, give me the 2 marks that why the lab assistant use ice. Okay. Why use ice? So you know, if you don't use ice, it's about you have to relate about the reaction that the reaction is a very or highly exothermic. So it releases heat, you know. If it releases heat, it may burn your skin. Yeah, it may burn your skin. So why lab assistant use ice? Because the reaction is very exothermic. I underline the word of very, mean that if you don't put the word of very, unfortunately, you won't get the mark. Because if exothermic, not necessary, you use ice. But when it comes to very, wow, it means release a lot of heat. It may cause the skin burn. Yeah. So the word of very here is a must. Okay. Then It's very isothermic. So what is the use of ice here? It can reduce the hotness, yeah, by absorb the heat release. That's why it can protect you. Or to avoid, we also can accept to avoid the beaker from breaking. Is if we release a lot of heat, the beaker will break as well. So we also can accept to avoid the beaker from breaking. All right. So I hope that you're able to understand why this reaction I need use ice. Okay. So about the calculation here, when 1 mole of sodium hydroxide dissolved in water, it produces 44.5 kilojoule. How about when you use 0.5? So what is the first, before you calculate temperature change, you need to give me how much is the heat released from the 0.5 mole of solid sodium hydroxide solution that dissolved in the water. So what is your first step? What is the heat change? Meaning that heat then released from the 0.5 mole. So 1 mole, the first step you need to write, 1 mole of sodium hydroxide released 44.5 kilojoule heat. If 0.5, you just do multiplication, which is 44.5 kilojoule times 0.5. So you will get 22.25 kJ heat. All right? So you will get this 1 mark. The last one, how you're going to calculate the temperature change, you substitute into the formula, which is what? Q equal to the MC theta. Q, you already get it. What is that? Is 22.25 times 1000 joule. Okay, why you need to use 1000 joule, 1 times 1000? Because you need to change to the unit of joule here. All right, so when you change to unit to joule here, so you divide with the MC here. M is at 100 from the distilled water, from the volume of the distilled water, and this is 4.2 is the fixed specific heat of capacity. So when you do this calculation, you will get 6.6 degrees Celsius. All right, so it's a very simple calculation. I know that you're able to calculate as well in the SPM. Okay, I know you can do it. All right, now we come to the question 5 here. All right, diagram below shows 2 different fuels that can be easily obtained in petrol station. The following chemical equations shows the complete combustion of gasoline and diesel. So I think this is about like we're asking you, this is also a hot question, which is used daily situation, that we pump petrol using diesel and gasoline. Which petrol you should pump? So why not we choose the higher heat of combustion? So the heat of combustion with diesel is greater than gasoline due to the higher number of carbon atoms per molecule in diesel. Describe an experiment to compare the combustion heat between the gasoline and diesel. Your description should include the procedure and step of calculation. So, can we continue to describe this procedure and step of calculation? So, how are we going to write the procedure? So, you can refer to this diagram. I'm very encouraged students to draw a diagram. So, from the diagram, we can deduce and how we're going to write the step here. So, the first step here, what is that? You look at the water here, the diagram, the water. So you must have the, this is the first step, yeah? Measure 100 to 200 centimeter cube of water and pour into a copper can. You can use, there's a tips that I was going to teach you. You can use like A plus B plus C. So what is A, B, C? A is an action. So the action must have like measure, pour, yeah. B is your bahan with the correct measurement or correct specification. Like bahan is your water, right? So you measure what is your specification. So you measure 100 or 200 centimeter cube of water. C is your container. You pour into the copper can. So you have a complete of ABC, then you can get a mark. Okay? So this is the tips that I can teach you. So after you measure and pour the 100 or 100 or 200 centimeter water in the copper can, so what's the next step? You must record, look at the thermometer here. You must record the initial temperature of water. Okay. So after you record the initial temperature of water, you must look at the glass lamp there, weigh and record the initial mass of lamp and gasoline. Because we need to use this data to calculate the heat of combustion. Okay, so after you weigh and record the initial mass of lamp and gasoline, first we use the gasoline first. So we need to place the lamp under the copper can and light the wick. Okay, don't use the word of burn. If you burn, it means that you fire up already. Then your all the light is on fire. Okay, you just light the wick. Use the word action. Light the wick. Okay, so precaution. Remember, you need to stir the water throughout the experiment. And when the temperature rise about 30 degrees Celsius, or if you want to put 40 degrees Celsius also can, put out the flame. When you put out the flame and record the highest temperature of water. Okay? After you record the highest temperature of water, remember there's another data that you need to record is weigh the lamp and record the final mass. Okay? Because you can calculate the mass of the gasoline that burned. Okay, so repeat step 1 to 7 with diesel. So this is the 8 steps that you need to write. Okay, so after that, so you just now the question said you need to include the steps of calculation. So what are the steps of calculation? You need to build a table like this, but you cannot just blank. There is no data. So be careful, student. Please write unknown, like mass of lamp. When you weigh the mass of lamp and gasoline before heating, so you write M1 here. This is the unknown that I mentioned just now. You use unknown. Okay. So there's another data is mass of land and gasoline after heating. So you can the mass you use M, right? So you just put M2. So how you gonna to calculate the mass of gasoline? Of course, it's M1. The mass of gasoline that burn, of course, is the M1 minus M2. Because before heating, the mass of the lamp and gasoline is bigger one value. So must M1 minus M2. All right. So still remember, you have to record the initial temperature of water. That's because later on we need to calculate the Q equal to MC theta. So initial temperature, maybe you can write like T1. Then highest temperature will be the T2. All right. Okay, so number of moles, okay, of gasoline, number of moles of gasoline is the mass of the gasoline that burn, which is M1 minus M2, gram, divide by the molar mass. So you can calculate the molar mass of the gasoline here. Okay. Then we come to heat release. Q equal to MC theta. So M is it you put 100 for the volume of water? If yes, you put 100. You put 4.2 here. Then the temperature change will be T2 minus T1. So the unit is joule. Yes. All right. So heat of combustion is, remember to put the word of negative Q. Q is 100. 4.2 here. T2 minus T1 here over the mole of gasoline is M1 minus M2 over molar mass. Remember, the final answer must have the unit. So your unit will be the joule per mole. Yeah, because this is joule, joule here, joule per mole. Yeah. Okay, so this is the whole calculation that you need to put in order to get a full mark here. Okay, I told you this calculation may up to 5 marks here. 5 marks. If you're able to give me all this data, all this step of calculation, for sure you can get this 5 marks here. All right, I'm sure you can do it. Okay, so we go to the next one. Okay. Oh yeah. After you calculate the heat of combustion of gasoline, so you need to conclude which heat of combustion is higher. So conclude here, heat of combustion of diesel is greater than gasoline. Okay. Okay. Question 6. I think is the last question here. Table below shows the value of heat of neutralization for the reaction between two different acids with sodium hydroxide solution. We can see the heat of neutralization using the HS is higher than ethanol acid. So what is the meaning of heat of neutralization? I think this all of you can do it because it's about heat change when 1 mole of water form. So remember, it's about 1 mole of water form from the reaction between the acid and alkali. Okay, so are you able to suggest acid HS? I think you're able to do it because HS must be strong acid as heat of neutralization here is higher. Okay, ethanol acid is a weak acid because heat of neutralization here is lower. So if you know HS must be strong acid, so what's the name of your HS? For sure is hydrochloric acid or nitric acid. Okay. Explain why there are differences in the value of heat of neutralization. Why there's a difference? Heat of neutralization using ethanol acid is lower. Why? So please write how is the differences in the value of heat neutralization. So you mention heat of neutralization that using ethanol acid is lower. Why? Because HS is a strong acid while ethanol acid is a weak acid. Then are you able to mention the third point? So you look at this diagram, look at the molecules of ethanol acid. So weak acid means that most of the ethanol acid still exists as a molecule. If still exists a molecule, heat that released during the reaction need to be absorbed by the molecules to break the OH bond for the complete ionization. Yeah, so that means when you use the weak acid, the heat of neutralization will be lower as the molecules absorb the heat that released during the reaction to break the OH bond. So how are we going to write here? So you can say most of the ethanol acid exists as molecule, meaning that some of the heat released is absorbed by the ethanol acid molecules to completely ionize the acid molecules. Yeah. All right, absorb. You need to say absorbed by whom? It's absorbed by the acid molecules for what? To completely ionize the acid molecule. Or you can say to break the OH bonds in the molecule. Okay? Yeah, simple, right? I think you're able to write it. So this is the end of my presentation for these two important topics for rate of reaction and thermochemistry. So here, student, please scan this QR code, or you also can click this link to go to the assessment. Okay, there's an objective question to you can do your own assessment on these two topics, rate of reaction and thermochemistry. I hope that you can answer all correctly. Okay, so all the best for all students here for your SPM next year. Okay, so thank you for watching this video and I pray for all the best for you all. Okay, so bye bye.